or other lines that we have here, but the main ones that we're going to go ahead and focus on are tangent, secant, and chords. And the other ones we should have been introduced to in our previous math classes, but we're just going to define them here again, okay? So with that said, let's go ahead and ask ourselves, how do you name a circle? So I'm going to go ahead and present you guys with my beautiful image of my circle. And my circle, guys, is has a center. I'm going to go ahead and call that my center, since it's a point that defines all the other points. So this is going to be called my center. And that center is going to be now having a circle around it. And we're going to go ahead and define our first term, which is circle. And it's the locus or the location of points in a plane that are a fixed distance. So all the distances that are away from it from a given point. So here's my center, that fixed point that's not going to move inside my circle, and all of the other points. So if I were to grab my circle and measure the distance from this point to this point, it would be the same measurement. From this point to this point, same measurement, and so on and so forth. So I go ahead and I'm able to construct my beautiful circle with all those points that lie equidistant or the same distance away from that fixed point, which is my center that I call here. So go ahead and copy the definition down on your first little box. Let me go ahead and show you guys your box. Let me see. Do I have my, yes, I do. So here's what you guys have in front of you, right? So you're gonna go ahead and write circle, my definition, the locus, of all the points that are the same distance away from the fixed point. And I'm going to draw that example, my illustration with my center C. Okay, just making sure everybody's on the same page, right? Everybody got the worksheet. Okay, perfect. Okay. All right, so back to my item here. So I have my circle, the locus of points in a plane that are a fixed distance from a given point. How do we name a circle? The way that we're going to go ahead and name a circle is that we're going to go ahead and write circle or a circle with a beautiful center, and we're going to label it by its center point or the point of center that it has. So in this case, it'll be my circle C. So whenever I'm talking about circle, this is circle C. All right. Everybody has this one? Anybody need more time? Okay. All right, so let's go ahead and go on to the next definition, guys. This one should be kind of not self-explanatory, but very, very self-explanatory. Where we discuss about interior and exterior of points that lie inside and outside of my beautiful circle. Now, the ones that are going to be considered to be interior of a circle, everything that's interior is going to be all the set of points that lie inside of a circle. So in this case, we have our image here, our illustration, and we have interior points here or an interior point. Which point do you see that is interior, inside of my beautiful circle? B in this case. So this case, my point B would be inside or in the interior of my circle. Now there's no center present, so we're just gonna go ahead and call it the circle. My next term that I have here is the exterior of a circle, and it's the set of all points outside of a circle. So all of the points that exist outside of my circle. I have many, many, many points, but we just have some that are present here or labeled. Which one is present here? C in this case. So my point C here is located on the exterior of my circle here. Now, point A is a different type of circle. It's not in the interior, it's not in the exterior, it's actually on the circle. So on the circle. So A would be considered to be on the circle. All right, go ahead and copy this down. So now we're gonna go ahead and go on to my lines that intersect my circles. Now, my circle here is called circle C, same circle. I'm gonna go ahead and introduce you guys something that you guys are very familiar with, which is radius. And radius is a segment with one endpoint on a circle and one endpoint at the center of my beautiful circle. So my radius in this case, I'm gonna go ahead and draw my first endpoint exactly on the circle. And the second endpoint is at the center of my beautiful circle. So this is what I'm gonna go ahead and call my radius, and I can go ahead and label my point here. For example, I can go ahead and label it A. So my radius would be my segment AC. I can draw another one. Let's go ahead and draw another one, another endpoint, all the way to my center. Let's go ahead and label this point. Pick a label. Pick a point. Z. Okay. So we have ZC. And one more. Let's go ahead and construct one more. And this one is going to have an endpoint at, pick another letter. X. Okay. So we have it at XC. Notice that they all include that center point as part of their endpoints. And we're going to go ahead and label it like that. All right. Now my next part here should be another familiar term, which is the diameter. We did this one with our beautiful activity. It's a segment with the endpoints on a circle and intersects the center. Does everybody have these points, these examples? I can go ahead and clear them out very quickly. Now let me go ahead and construct a beautiful diameter here in this case. So here's my beautiful diameter, my endpoint. It goes through my center and it has another endpoint on the circle. I'm gonna go ahead and label these parts, let's say D and F. So in this case, my beautiful diameter would be DF. My segment DF. And it has to be a segment, guys. It can't be a line, just a segment. Here's another one, my endpoint, my center, and another endpoint. Let's go ahead and label this E. Let's say EG. So here's another one, EG, and it has to be a segment. All right, go ahead and copy these down. The first one that we're gonna go ahead and call is a chord. And a chord is defined as a segment whose endpoints lie on the circle. So notice that this is very, very similar to what we already seen, but yet a little bit different. Now, this is an example of a beautiful chord. A chord states that I have my segment and I have my endpoints that lie on a circle. So I'm gonna go ahead and draw one point here. I'm gonna go ahead and label this one A, and I'm gonna go ahead and draw another point here. I'm gonna go ahead and label this one B. And I'm going to draw or construct a segment from those 2 points. Now, does it fit my definition? A segment whose endpoints lie on a circle. These 2 points lie on a circle and I have a segment. So therefore we have a beautiful chord. So here in this case, a chord, we're gonna go ahead and label it as AB. And we have to label it as a beautiful segment. So segment AB. What would be another example? Pick 2 points. E and F. So E is over here. Here is beautiful F. I'm going to construct a segment with those 2 endpoints. Therefore, I have E and F. Bless you. And one last one. I'm going to construct another endpoint right here. another endpoint at B. And I'm going to construct a line that goes through C and B. Now, is this considered my diameter? Yes, it goes through my center, but it's also considered a chord. So let's go ahead and label this one. Let's say DFG. This will be my chord GB or BG. Okay, now my next one, guys, I have a secant. Secant is very not similar, but it's going to be just a little bit different from my beautiful chord. And a secant is a line that intersects a circle at 2 points. Notice here that it says segment and it says line. So there's a difference here. We have a segment and we have a line now. Now my line is going to be considered a line. Yes, it does pass through my beautiful circle at 2 points. So I'm going to go ahead and construct my line here. And then my line, go ahead and make it over here. Let me label these, for example, let's say X and Y. So here's X, here's Y. But this time it has to be a beautiful line that passes through these two beautiful points. So at how many points does it pass through my beautiful circle? It passes exactly through 2 points. So I need those 2 points. I have X and Y. So this is going to be XY and it has to be defined as a line. So line XY or line XY. Okay. These two next topics are very, very different from what we did in trigonometry. Tangent, yes, we did have our opposite over adjacent, but this is a different type of tangent that pertains to a circle. And the word tangent basically means that it's going to touch my two objects, or two objects are touching each other, but exactly in 1 point. So only 1 point and 1 point only. So this means that I'm going to have my tangent line, and it's the same, a line that exists in the same plane as my circle, and they're going to intersect exactly at 1 point. So let's go ahead and construct my 1 point. What do you guys want to label your point? Let's label it D. And I'm going to construct a line. And my line is going to go through that point, and it's going to intersect my circle at exactly that 1 point. Now, there's different ways to label this or call this line. If there's another point that lies on that line, for example, E, point E, we can go ahead and call this beautiful line DE. But sometimes it's going to be assigned a cursive letter. So for example, L, it can also be line L that is present there. So it's either going to be labeled as a line with 2 points, or it's going to be labeled as a line with a cursive letter. Okay, so pick another point. I bet Eric, give me another point. E, okay, where do you have E?
Oh, sorry, H.
H, okay. So let's go ahead and label out this one, H. And let's go ahead and draw another tangent line that goes exactly through that point. Beautiful. And this one is labeled M. So what is the label to this line? It would be M. Okay. Now the last one, the reason why I say you guys can go ahead and write in the same box is because it's the point of tangency. And the point of tangency is the point where the tangent and the circle intersect. So where is my point of tangency here? My first line at D. And the second point that I have here for line M, it would be H. So those points exactly where they intersect, they're going to be considered my point of tangency. H and D in this case. And if I were to construct another one, it would be that same point and so on and so forth. So very similar yet different. So How do you guys see different, or how do you see, or how is a secant different from a tangent? Go ahead and tell your neighbor. How do you think is a secant different from a tangent? Going away, please. Thank you. All right, my question was, how is a tangent different from a secant? How can you tell the difference between those two items? A ver, Diego Zambrano, help me out here. How is a secant different from a tangent? Tangent only goes through one point. Now, my next question is, how is a chord different from a secant? One's a line and the other one is a segment. So also, whenever we're labeling them, we have to make sure that whenever we're labeling a chord, it has to be a line segment. When we're labeling a secant, it has to be a line. So there's a difference between the items. They might have some similarities, they might have some differences. We just have to be careful and pay attention to precision here. All right. I made this available for you so you guys can see them. Now, here's my first example for today. Identify each line or segment that intersects my beautiful circle A. So I gave you guys a list. Identify my chords, my tangent, my radii, because I have many of them, and secant and diameter. All right, go ahead and copy this one down. Just like that. So here goes. I'm gonna go ahead and label the first one or identify my beautiful chords. So what is the definition of a chord? It's a line segment that goes where? You guys have the definition?
Oh yeah, you have none. You have none.
Do I have some chords.
Oh yeah, isn't it here?
It's a line segment. It's a line segment that lies, its endpoints are on the circle. So let's go ahead and identify any line segment that has endpoints on the circle. So let's go ahead and look for the first one, B and C. So therefore, BC is my first chord. It can also be a diameter, but it's also considered a chord.
Oh.
So I have my first one, BC. My second one, I think I have another one. Endpoints that lie on my circle. So we have another F and E. So EF in this case, but it has to be the line segment EF. The line lies on it. The segment EF is considered a chord. Huh? It doesn't necessarily need a line. The endpoints of this segment, I'm just cutting at the segment and I'm only considering that segment to be my chord. If I were to talk about my line, EF, then that's a whole different story. Now let's go ahead and go on to tangent. Where's my tangent line here? C, but it's labeled with another point or with a cursive letter. So it would be L in this case. So it's my whole line right here. Here's my line, tangent. It intersects exactly at one point and it's my point C. And it's labeled with a cursive letter. If we were labeling it with points, we need a second point. All right, next one, let's see, radii.
Oh, BA and CA.
BA and CA. So I'm gonna go ahead and identify a B and a C. And remember that they have to be line segments, so AC and AB. Do we have more than that? No, that's it. It has to come from the center and it has to have the second endpoint on the circle. Okay. All right. Secant. In this case, it would be more specific than EF.
Line here.
Line EF. There you go. Line EF. So line EF. And make sure that you guys label it as line. So we have to be very, very specific on how we call these parts. And the last one, my beautiful diameter. It would be my entire segment here. BC, all the way. I meant to highlight it. BC. It goes to my beautiful center, point A, and it goes now through there. My line segment BC. Not too bad, huh? Okay, you guys want to try one on your own? Yes, Miss Vasquez. Okay. All right, go ahead and try this one. Number 2, and this is the last one for today. Last one. Go ahead and try this one. Last one. So for the first one, let me go ahead and bring back my random number generator. So for the first one, go ahead and give me one chord. One chord. Which one? ST, endpoint here, and a line that goes through it. And it goes exactly to 1 point. Awesome. ST, more specific, line or segment? Segment, there you go. So ST, and it's a segment ST. All right, I'm gonna let you pass it on, Haley. Eric, let's see, do I have another chord here? I have one more. QR in this case, but it has to be segment or line? Segment, so segment QR. Perfect. All right, pass it on, Eric. Jimmy, tangent, my tangent line. I only have one. It would be UV specific, line or segment? Line UV. So I have to say UV, and it has to be my line UV. Or you can say line UV if you can't spell it. I mean, if you can't do the any of this. Now, Jimmy, pass it on. Edric, radii, go ahead and give me one. Which one? Radii is multiple radius, so radius. They're multiple. So we have more than one. So give me one. Radius. It has one. What's the definition? Look at the definition. So where's the center of my circle? P, okay. So from here, one of the segments that has a point or another endpoint that lies exactly on the circle. So which one? Which one? Okay, point T, so that segment is called? So what is it called? Label it. From point, from the center to the endpoint. With the points, the labels. What is the center? PT, there you go. PT, thank you. All right, pass it. Well, go ahead and label, find me another one. Yeah. PS, there you go. And the last one. Yep. QP would work too, or PQ as well. Either way it would work. All right, hold on. All right, now my next item, secant. Where is my beautiful secant? Edric, pass it on. Who? Alex, secant. ST, line ST, there you go, line ST, you're right. Line ST, do we have another one? No, the other one's a segment that doesn't go on. It has to have our beautiful arrows in order for it to be considered a line. So if it doesn't, it's just considered to be a beautiful, just segment. All right, Alex, pass it on for the last one, diameter. Miriam? Miriam? My diameter, yes. ST, and is it a line or a segment? Segment. All right, so we have our beautiful segment from S to T, and it goes through beautiful P. All right, any questions on all of this? No. All right, so we should be able to identify all the parts so far.